Hello, I'm Mark Hainsworth, Quantitative Literacy Director at Emory and Henry College, and I'm here speaking with Dr. Laura Hainsworth, who is a member of our chemistry department. There's no relation between both of us. Actually, Laura's my wife, and I've made her come in and do this discussion about QL with us as well. You are a member of the chemistry department and also a member of the environmental science department as well.
Right, the Environmental Studies Program.
Studies program, okay. And so, Laura, could you tell us about the classes that you typically teach here at Emory?
I teach classes in the chemistry department, and that would be general chemistry, and I also teach analytical chemistry and instrumental analysis.
Okay.
Then in the Environmental Studies Program, I teach the Introduction to Environmental Studies, and I teach environmental monitoring, and also a senior seminar.
Nice, nice. Would you tell us also about specifically the classes that you've designated as QL intensive, and kind of why you've done that?
Sure. I teach 2 QL intensive classes. Analytical chemistry is one of them, and environmental monitoring is the other. Analytical chemistry is really a fundamentally quantitative course. And in fact, in many institutions, the class is called quantitative analysis. Mm-hmm. And so the QL component in that, the whole class is quantitative. Mm-hmm. We do statistics and we do calculations, and the entire class really is quantitative, dealing with chemistry data in a quantitative way. The other class is the environmental monitoring class, and that is also pretty fundamentally quantitative because we talk about how to measure environmental parameters, things that are important in the environment, stream pH, that kind of thing. And then we do calculations with that and represent that data.
Great, great. So could you tell us specifically what are the QL goals, or what are the QL skills that you're hoping that your students learn or maybe enhance due to this course?
I want them to be able to take measurements in the environment and then carry out calculations with those measurements. They might have to do a series of unit conversions on those concentrations or parameters, or they might have to do a calibration curve to analyze the sample with an instrument. So I want them to be able to take measurements in the environment and convert them into meaningful data, and then also to graph them and represent them in a meaningful way, to represent their data and describe their data in a way that would make sense to an observer.
So your students have to do specifically to show you that they've learned these skills and they've satisfied the requirements for your class. What are the actual projects?
We have I have 3 projects in my class, and they all deal with the laboratory portion of the class, although I do spend lecture time preparing the students for this. In one project, they collect soil samples from around campus, and they do an analysis for lead content in those soil samples. So they have to do the chemical analysis, and then they have to use an instrument, and they have to analyze standards and come up with a meaningful concentration for the lead concentration in the soil.
And all lead levels are at 0, is that right, around this campus?
I also have them carry out a weather station lab activity where they spend a week monitoring the weather using our weather station that we have on campus, and they collect data and they graph their data for their weather week, and they compare it with predictions that they have seen in the media and also observations that they've made on their own. And so they get a really good introduction to graphing and also to making sense of the data and analyzing and explaining the data that they've collected. And then finally they have a semester-long project where they will monitor a stream site for a variety of different parameters. They measure pH, nitrate concentrations, phosphate concentrations, temperature, dissolved oxygen, turbidity over the course of the entire semester. So at the end of the semester, they have to put together a report. They have to, again, make calculations based on those data and graph the data so that it makes sense to an observer, and so that we can share this with other local environmental professionals.
Do your students give presentations as well?
They
not
do.
Just a paper?
They do. They give oral presentations where they have to describe what they've done, and they have to defend their data. I will always ask questions about, why they think some result is higher than some other result. And then they also give me a written report.
I see. What kinds of things have you seen come out of this, these efforts to sort of focus more heavily on quantitative literacy? Are you seeing their skills improve? Are you seeing them use it again somewhere else where maybe you haven't asked for it? Or?
Yeah, what I do tend to see is that students who have taken this course are interested and willing and excited about doing other projects around the region and for other classes. So I've had students that have taken my class take on a rainwater pH project on White Top Mountain as their senior seminar project. So they've been collecting rainwater samples. They have to measure rainfall by measuring the volume of rainwater that they collected and the area that they collected in, and also make pH measurements and other nitrate concentration measurements in those samples. And so they came into that project with the basic skills that they needed to make it successful.
Great. What kind of advice would you have to anyone else that's maybe thinking about incorporating QL into their classroom?
I guess my advice would be to don't assume that your students remember a lot of the basic math skills that they've learned in their math classes. And it's a different beast when you take equations and then you have to put real numbers into them and make them make sense. And so things like unit conversions, I really spend time practicing those during the course of the class so that they can review them and I guess get used to doing math with real numbers in it.
I see. Do they typically need help with software or anything else? In addition to the unit conversion sort of.
Some do, but many of them, by the time they get into this class, are familiar with graphing on Excel. Excel is what we mostly use for graphing, or they can use the chemistry software as well. But usually they use Excel, and usually they do pretty well. It's good practice for them.
Great. QL in a classroom is worth the effort.
Oh, absolutely. In the classes that I teach it, absolutely. You couldn't be a proficient environmental monitor without a significant level of quantitative reasoning skill.
Great. Well, thank you for your efforts and thank you for your time here, and we appreciate it.
You're very welcome.